so first we have the FRQ that talks about the derivative function. Now, actually, the first two FRQs that I've sent you are not BC specific, but it's not going to be a bad idea for us to go over this in case this content shows up in a BC question in the midst of it. So we'll do those. Okay. So it says the derivative of the function is given by f prime equals. So f prime equals x minus 3 times e to the x for x is greater than 0, and f of 1 equals 7. So that's the pertinent information from the prompt. And then part A. The function f has a critical point. So f has a critical point at x equals 3. At this point, does f have a relative min, max, or neither? So min, max, neither. That's the question. Okay, so if I am looking at what I've been given, I've got f prime. I don't have f, and I don't have the second derivative, although I could find both potentially. So let's see what we would want to do. I think I might just go ahead and use the second derivative test to test for extrema, just because it's easy, but at the same time, I guess I have the first order, so I could do a sign chart. Let's just go ahead and try a sign chart, and then we'll go from there. So f prime, critical point at 3, right? So if I plug in 3, I know the derivative is 0. Okay, so that's important. And then f prime at, say, 2. 2 minus 3 is negative, e to the second is positive, so this is going to be a negative. And then at 4, that's going to be positive. So I think it's clear enough that we could say if f is doing this, then we have a minimum. So I would say f has a min at x equals 3 because f prime changes from negative to positive. I'm kind of curious to see if the second derivative test would work. So right quick, I'm just going to find the second derivative. F double prime of x equals, so we would have to do product rule. First times the derivative of the second plus the derivative of the first times the second. So that's just e to the x factored out, x minus 3 plus 1, so x minus 2. So if we were to plug in 3, we would get e cubed times 1, which is greater than 0, so that's positive. If f prime at 3 equals 0 and f double prime at 3 is positive, then we're talking about that point right there. You got your minimum because you're concave up and you have a slope of 0. Then f has a min at x equals 3. So just a reminder of what the second derivative test for extrema is. Okay, and that's all we need to do on that part. Part B asks, on what interval, if any, is the graph of f both decreasing and concave up? F both decreasing and concave up. That's on what interval, if any. So explain your reasoning. Okay. So in order to be decreasing, in order for f to be decreasing, that means f prime must be negative. In order for f to be concave up, that means f prime must be increasing, or the second derivative is positive. So what I think I'm going to do is I'm going to look for, I'm going to do a sign chart again for all my critical points for f prime, and then I'm going to do, for f double prime, I'm going to figure out when f double prime is positive, and I'm going to see when those are the same, when those are coincide, okay? So f prime, if we look at f prime, it only has a critical point at 3. That's its only critical point, and then because e to the x never equals 0. So for f prime, sign chart, we already know negative, positive, right? So for f double prime, I'm looking at f double prime, so I already found it. okay? And if you didn't factor out the e to the x, it might be kind of awkward to figure out your critical point, but it is just factoring out the e to the x, and then you got x minus 3 plus 1, so x minus 2. So here's what I know. The second derivative equals 0 at x equals 2, which is a possible POI, and it is a POI because this is going to change sign at 2, but anyway. So here's 2. So I'm going to offset that from the 3, right? So if my f double prime equals e to the x times x minus 2, when I plug in 1, I get a negative, and when I plug in 3, I get a positive. So when is f prime negative and f double prime positive? F is both decreasing and concave up when f prime is negative and f double prime is positive. And this only occurs on this window right here from 2 to 3, because f prime is only negative up to 3 and f double prime is positive starting at 2. So I would say on the interval 2, 3. And there we go. Okay. And then the last part, it says, part C, find the value of f of 3. Okay. So f of 3, interesting. There's a couple different ways to do this. We need to antiderive. We could do, and by a couple different ways, I mean obviously we got to antiderive. But the question is, then do you I don't think this is an AB question. Nope, definitely a BC question. Good. Okay. Do you do like the plus C and then you solve for it, or do you use the fundamental theorem of calculus? It's totally up to you. But I'm going to explore that. Okay. So like I said, a couple different ways. We could do f of I'm gonna do this. The antiderivative of f prime from 1 to 3 equals the antiderivative of f prime is f at 3 minus f at 1, right? So this, sorry, that was not visible. The antiderivative from 1 to 3 of f prime equals f of 3 minus f of 1. So this is using the fundamental theorem of calculus. Some of you would think to do this, some of you would not. Some of you would think, well, let me just find the antiderivative of f prime in general. And then I get f of x plus c, solve for c. And then once I have that, then I can plug in f of 1 equals 7. Well, that's to plug in for that. And then plug in x equals 3. And then there you go. So some people, this method speaks to you. Find the antiderivative plus c, solve for c, and then plug in 3. For some people, this might make sense to you. The integral of f prime from 1 to 3 equals f of 3 minus f of 1. So to find f of 3, we just add f of 1 over. So f of 1 plus the integral from 1 to 3 of f prime of x dx. So I'm going to do it this way, and then I will see if what it would look like over there. Okay. So f of 1 is 7. And the reason why I did 1 to 3 is because that's a value I knew, f of 1, right? So that's going from a value I know to a value I don't. Plus the integral from 1 to 3 of f prime, which is x minus 3 e to the x, and then dx. And that's going to equal f of 3. So let's start working that out. The only way that I'm going to antiderive this, you could split it up and say the integral of x e to the x and then minus 3 e to the x, and then just do integration by parts with the x e to the x, but we might as well just do the whole thing at one time. So we've got u du v dv. In my LIATE, exponential is the last thing you pick for u because you do need that to go down, and so we'll pick the algebraic x minus 3, and its derivative is just 1 dx. We'll pick e to the x dx to be dv, and then the antiderivative of that is e to the x. So we've got 7 plus I'm going to go ahead and write this out, and then we'll do the 1 to 3 in just a minute. So we've got uv, x minus 3 e to the x, minus the integral of v du. So v du e to the x dx. Right? So this technically is from 1 to 3, and this is from 1 to 3. I tend to like to wait until I'm done with anti-deriving that, and then just say from 1 to 3 for the whole thing. So 7 plus x minus 3 e to the x minus the antiderivative e to the x is e to the x, and so then all that's bar from 1 to 3. Okay, so 7 plus, and then I'm going to plug it in. Okay, so I've got 3 minus 3, that's 0, minus e cubed, so negative e cubed, minus, so plug in the upper limit, minus plug in the lower limit. So if I plug in 1, I get negative 2e to the first minus e to the first. So that should be good enough, although if I simplify that, it could be minus 3e, so plus 3e. So 7 plus 3e minus e cubed, and that is it. 7 minus e cubed plus 3e. Okay, kind of want to play with it over here. If I antiderive this, so if I just said find the antiderivative of x minus 3e to the x dx, we would have gotten this whole x minus 3 e to the x minus e to the x and then plus c. So we would say f of x equals this. F of 1 equals 7. So we would have said 7 equals negative 2 e to the first minus e plus c. So then c would equal 7 plus 3e. So then we could say f of x equals x minus 3 e to the x minus e to the x plus 7 plus 3e. You can't even see that. That's rude. Okay, so f of x equaled this antiderivative plus c. F of 1 equals 7, so 7 equals plug in 1, c, and then solve for c. So c equals 7 plus 3e. And then f of x equals x minus 3 e to the x minus e to the x plus 7 plus 3e. And then we can plug in f of 3. You plug in 3, this is 0, so this is negative e cubed plus 7 plus 3e, and we get the same answer. So that's another way to do it. Okay, and that's the first FRQ for today. Let's talk about the second one. Let f be the function defined for x greater than 0, so we've got x greater than 0, with f of e equals 2, and f prime is given by x squared natural log of x. Okay? Write an equation for the line tangent to the graph at the point E2. So we need tan line at the point E2. So tan line, we know y minus and then x minus. It's at the point E2, so we've got e for x, 2 for y, and then we need the derivative at the point E2, so all I need to do is plug in e into my first derivative, and there we go. So f prime at e equals e squared natural log of e, which is 1, so e squared, and that should be all we need. Yeah. Okay, part B. Is the graph of f concave up or concave down on the interval from 1 to 3? Give a reason for your answer. So f concave up or down on the interval 1, 3. Okay. In order to figure out concavity, I'm going to have to figure out the second derivative and do a sign chart. So we're going to find the second derivative. F double prime equals first times the derivative of the second plus the derivative of the first times the second. So that becomes x plus 2x natural log of x. So I'm going to factor out an x, and I'm left with 1 plus 2 ln x. And the reason why I want to do that is because setting it equal to 0 is much easier if you factor. So I know x equals 0, and that would be 2 ln x equals negative 1, natural log of x equals negative 1/2. That means when or x equals e to the negative 1/2, or 1 over the square root of e. Very interesting. 1 over the square root of e. Okay. Although I probably don't need this, but... Okay. So, well, looking at it, they didn't bother doing this, so I'm going to talk about what I've done and then what they did without needing to do this. I find that my possible POIs are 0 and 1 divided by the square root of e, which is less than 1. Right? And our question is, are we concave up or concave down from 1 to 3? So this is the span which we're interested in. So really I just need to know what my second derivative sign is after these points over here. So that's kind of cute. But at least I know that it's not going to change on the interval from 1 to 3, although that was kind of implied in their question. So if I pick anything greater than 1 divided by the square root of 3, like say 1, then I can say that the second derivative is going to be 1 plus 2 times the natural log of... natural log of e is where it crosses the x-axis. Let me think for a second. Oh no, natural log crosses at 1. Not e. Natural log of e is 1. Wow, that was bad. Okay. Sorry, I was mixing that up. Natural log crosses at 1. Okay. So from 1 to 3, anything I plug in greater than 3, natural log is positive, this is positive, that's positive, because we're plugging in numbers from 1 to 3. So that means the second derivative would be positive on the interval from 1 to 3. And I think we could have just talked that out. This is what they did. But I would just say f double prime is greater than 0 for x greater than 1 over the square root of e, although you could have just said from 1 to 3 if you explained you could have just said because x is greater than 0 and natural log of x is greater than 0 for x greater than 1. So if you just said that, I think that could be an equivalent or an acceptable justification. F double prime is positive for x greater than square root of x greater than 1 over the square root of e. Therefore, f is concave up on the interval from 1 to 3. Your second derivative is positive. Okay, let's go to part C. Use antidifferentiation to find f of x. So, C. Find f of x. Okay, we've got a first derivative of x squared, natural log of x, which is definitely not a u substitution because, I don't know, you would pick maybe x to be u, but then you got x squared outside that you don't really, you can't replace with du, so it's definitely going to be an integration by parts, and in fact, I hope that you would notice that it would be an integration by parts twice, because, I think, let me see, because your x squared is going to have to go down twice in power, 2x and then 2. But maybe not. Let me see. Oh no, we we don't need to do that. Okay. Okay, I need to remember my acronym. Like I already thought exactly. So, yeah, the only way to antiderive natural log of x is with integration by parts. So, we can't pick that to be dv, because you can't just antiderive natural log of x. So we do have to pick that to be u. So I think we only actually have to do it once. Okay, we'll see. So, u du v dv. So, we want to antiderive x squared natural log of x dx. So we're going to let natural log of x be u. So that's 1 over x dx for the derivative. And then we want x squared dx to be dv, and the antiderivative of that is 1/3 x cubed. Okay? So then the antiderivative of that is going to be uv. So I'm going to put 1/3 x cubed natural log of x minus the integral of v du. So minus the integral, I'm going to go ahead and put 1/3 the integral of x cubed times 1 over x dx is just going to be x squared dx. So x cubed times 1 over x is just x squared and then dx. Okay, well that I can antiderive. So that's going to be 1/3 x cubed natural log of x minus, add 1 to the power, divide by the new power, so it's going to be x cubed, add 1 to the power, divide, so that's going to be 1/9 x cubed plus c, and then I know that f of e equals 2. So we're going to use that to solve for c. So 2 equals 1/3 e cubed natural log of e, which is 1, minus 1/9 e cubed plus c. 1/3 is the same thing as 3/9, so 3/9 minus 1/9 is 2/9. So 2 minus 2/9 e cubed, although if you just wrote that plus, minus that plus that, that'd be just fine, because you don't have to simplify. So final answer, f of x equals 1/3 x cubed natural log of x minus 1/9 x cubed plus 2 minus 2/9 e cubed. And I'm pretty sure that's it. Let's see. Yep, and we're good. Okay. So that's the second FRQ, and let's get to the third. So the third FRQ is a little interesting. Sorry, I gotta check something real quick. Okay. So the third FRQ starts with, consider the function f of x equals 1 over x squared minus kx, where k is a non-zero constant. The derivative of f is given by, so f prime is given by k minus 2x over x squared minus kx quantity squared. So that's okay. Chain rule. And a, let k equal 3, so that f of x equals 1 over x squared minus 3x. Okay, write an equation for the line tangent to the graph of f at the point whose x coordinate is 4. So tan line when x equals 4. Okay, so y minus, and then x minus, x equals 4. We gotta plug in 4 and get y, so honestly we could just do 1 over 16 minus 12, which you could say 1/4. And then we need the derivative, so we just plug that into f prime. So I'm going to plug 3 in there and say 3 minus 2x over x squared minus 3x quantity squared. That's f prime. For this part A, if k equals 3. So then the derivative is going to be f prime at 4. It's going to be 3 minus 8, so negative 5 over, and in fact you could just write 3 minus 2 times 4 over, and then plug in the 4, and then just say let that equal a, or like let that equal capital M, and put capital M right there. That's perfectly fine. So 16 minus 12 is 4, 4 squared is 16, so we could say negative 5/16, and call it good? Yeah? Okay. So tangent line. B. Let k equal 4, okay, so that f of x equals 1 over x squared minus 4x. Determine whether f has a relative min, max, or neither at x equals 2. So min, max, neither at x equals 2. Okay, let me think. How would I want to do this? Might just find the second, or deal with the second derivative and talk about sign chart. Or sorry, first derivative. I don't think I want to find the second derivative. So I'm going to say f prime equals k equals 4, so 4 minus 2x over x squared minus 4x quantity squared. So if I were to set this equal to 0, I know x equals 2 is when the numerator equals 0. The denominator is x times x minus 4 and then quantity squared, which still means it's undefined at x equals 0 and at x equals 4. So as far as my critical points go, 0, 2, and 4. So I'm going to plug in values on my sign chart on either side of 2 into my first derivative. So if I plug in 1, I get, that's a positive. It is important though that you recognize 0 and 4, because if you just had 2 on there and then you chose, like say negative 1 and then you chose 5, then you could get a false reading. Although I don't know why you would choose those numbers, but it is, it could change at 0 and at 4 as well. Although with it being squared, I don't think they will change. Interesting that they would choose that to do that. Okay, so 1. That's positive. Everything squared is positive, so positive. 3, that's going to be negative. So I would say f has a max at 2. Let's make sure that's all they're looking for. Interesting. Okay, so one of the points that they gave was whether or not you considered f prime at 2. So they didn't tell me that f prime of 2 was a critical point, but I did identify them here. And so that is how I would have obtained the first point. You have to first identify whether or not you even have a critical point, because they didn't say it was a critical point. So very important that we say critical point, x equals 2, because if the slope hadn't been 0 there or undefined, then it's neither, and that would have been your justification. So as it is, I'm going to say f prime of 2 equals 0, and f prime changes from positive to negative at x equals 2. Therefore, f has a max at x equals 2. Okay. Let's look at part C. Find the value of k for which f has a critical point at negative 5. K equals what if f has a critical point at x equals 5, negative 5. Okay, so that means the derivative will have to either be 0 undefined at x equals negative 5. I think that's pretty clear. In fact, I feel like all you gotta do is think about the numerator, but let's just see. Okay, so f prime is going to be k minus 2 times negative 5 over Negative 5 squared, so 25 minus 5, no, minus k times negative 5, so plus 5k. This will equal 0 when k plus 10 equals 0, and that's when k equals negative 10. So there we go. The derivative equals 0 when k equals negative 10. Yeah. You could say it's undefined if k equals negative 5. Interesting. 25 plus 5k. K is negative 5, then this is undefined, so I don't know why they wouldn't identify negative 5 as also a critical or a value of k for which you have a critical point. But they only addressed the numerator. Interesting. Okay. Part D. Sorry, give me a second. Okay. So part D says let k equal 6. We're just going all over the place with k. So that f of x equals 1 over x squared minus 6x. Find the partial fraction decomposition for the function f, and then find f, the integral of f of x. Okay, so partial fraction, and then find the integral of f of x. Alright, looks fun. So we've got 1 over x squared minus 6x equals a over, I'll go ahead and go with x, plus b over x minus 6. So that means 1 equals a times x minus 6 plus b times x. If I let x equal 6, then that means b equals 1/6, and if I let x equal 0, that means a equals negative 1/6. Interesting. Okay. So that means that the integral of 1 over x squared minus 6x dx is equivalent to finding the integral of, well, I'm going to go ahead and say a is negative 1/6, so I could write negative 1 over 6x, but I'd rather write negative 1/6 the integral of 1 over x dx, and then plus the 1/6 the integral of 1 over x minus 6. So I'm going to separate the coefficient from the expression. And then the antiderivative of 1 over x is natural log the absolute value of x. So negative 1/6 natural log of the absolute value of x, plus, and then the antiderivative of that, u is going to be x minus 6, du is dx, so there's no real reason to use a u sub. Although if this had been 6 minus x, it would have been a completely different thing. You'd have had du is negative 1. But it is 1/6 natural log of the absolute value of x minus 6 plus c. Let me see. Yeah, that's what they have. So we're good. They did go ahead and combine your two logarithms. You don't have to, but they're saying if you have a logarithm separated by subtraction, you can combine them using division. So that means like 1/6 out front. Natural log of this one is the positive one, so it goes in the numerator, and then subtract that. You can see it as that, and then plus c. But stopping here is just fine. Okay, there are those 3 FRQs.